All right, so first thing we got to do with this one is take the 1/2, and we're going to put it as an exponent inside. Remember, when we were expanding, then we were taking our 1/2 and putting it out, right? All right. Hey, 25 to the 1/2 power. Yes. Why? Because the 1/2 power tells me square root, right? We should be able to look at those things interchangeably now. All right. So this is log of 5 plus log of 4. And then I'm going to use my multiplication property to turn that from a sum into a logarithm. You should take these notes. All right, which turns out to be log of, so we've written that as 1 logarithm. Okay. Let's do another one. So again, I'm going to take that 1/3 and I'm going to put it inside my logarithm as an exponent. So that's going to be, what is 8 to the 1/3 power?
2.
Yes! And then, is it fair, can I just say, hey, we're going to have to multiply these, right? We'll put them as a single logarithm. So then that should be log of 32. Page number 84. 84. Thank you.
Herbert, is that you?
Okay, let's do another one. So I'm going to write this as the log of 5 to the 3rd power plus the log of, I don't know, let's call it, I don't know, I could do 1 times 8, or I could call it, let's just call it 8. That's 8 tenths. All right. So that's log of 125. And then this one, remember I have the property that tells me that I can write this as log of 8 minus log of 10. Right? If I have a quotient, I can then express that as a difference of 2 logs. And we're almost done. If this didn't have a numeric value, right? It would be done. But what is log base 10 then?
Log base 10.
It's 1.
Yes.
Good job. Oh, that's not what he said. And there we go. That's our final answer to that. Hey, let's expand these. Oh, that looks so cool.
Yeah, Mr. Dorman, that looks awesome. Come here, Mr. Dorman. I want to be like you. That's my friend.
He was like, yes, please. Okay, so I'm going to write this as log of 3. And now I need to take the the squared out. And I'll take the 5th power out, the 5 out there. Alright. Let's do it again. First of all, I'm going to write this as x to the 7th, y to the 3rd to the 1/2, right? I'll write it as a rational exponent first.
Did you do the test quizzes?
The quizzes? No, but they're all scanned and everything. Alright, I'm going to take that 1/2 and put it out to the front. Just like so. Now we do things over yonder. Alright. We can still break it down.
Broke it down.
Break it. Break it. Break it. Alright. Okay, so I'm going to write this as a sum of 2 logarithms, but check it out. One of the most common mistakes that students make is when they break this up, this 1/2 is only going to go with the log x to the 7th and not go with the log y to the 3rd. And that would be a wrong thing to do. The 1/2 belongs to both of them, right? Since it's out in the front before we broke it up, it needs to go with both. In other words, right, we got the 1/2 there. We also need the 1/2 over here.
What would we put in it? Like the 7 in front of the long.
We do. We surely will. As sure as the stars shine in the sky. So that 7, if I multiply 1/2 times 7, I get 7/2, right? And if I multiply 1/2 times 2, I get 3/2. And there it is. moving right along. Now it is time for solving. Okay, so we're going to learn how to solve exponential equations using logarithms. So what this says is that I can take the log of both sides, just like I could divide both sides by a number, or I could multiply both sides by a number, or I could add a number to both sides of an equation, and so on, right? I can solve these equations by taking the log of both sides. So that's what I'm going to do. I'm going to write this over here because Eureka didn't give me a lot of room. So I'm going to take the logarithm of 10 to the 10x, and then I'm going to take the logarithm of the other side. I'm allowed to do that.
How are you sure about that?
I know they wait. So now I'm going to take the exponent out. Hey, what is log base 10 of 100? In other words, 10 to what power is 100? So this is 2, right? Hey, log base 10 of 10 is what? 10 to what power is 10? 1. So that's going to go away. So then I'm left with x equals 10, 2/10, right? If I divide both sides by 10. Which turns out to be 1/5. Let's see that again. All right, let's do it again. So I'm going to take the log of both sides. I'm going to just write it up here so I have a little more space. So that's going to be log of 10 to the x minus 1 equals log of 1 over 10 x to the x plus 1 power. Yay. Yay. So first thing I'm going to do is I'm going to put that x minus 1 out to the front. And then if you look at your properties at the back of the lesson, property 7 says that if I have the log of 1 over x, I can write that as negative log of x. So I'm going to use that right now. So this is going to become negative log of 10 to the x plus 1. All right, log base 10 of 10 is 1, so all I have left over here is x minus 1. And here I need to bring this out to the front, but there's a negative sign there, right? So the negative sign is going to multiply everything that I brought out. All right, so this becomes x minus 1. I distribute that negative sign, I get negative x minus 1. And log base 10 of 10 is 1, so that's going to go away. I add x to both sides. And get 2x minus 1 equals negative 1. I add 1 to both sides. And I get 2x equals 0. So then when I divide both sides by 2, I get x. Let's do it again, guys. All right. Let's take the log of both sides. Log of 100 to the 2x power equals log of 10 to the 3x minus 1 power. I'm going to pull my exponent out. On both sides. And now I can get some numbers for these logarithms. Log base 10 of 100 is
2.
That's correct, because 10 squared is 100. And log base 10 of 10 is 1. So this becomes 4x equals negative 3x plus 1. Now I just got to add 3x to both sides and we're done, right? And I get so then x is going to be 1/7, right? Yay. Alright, keep going. Thanks so much. Do you have a question? No.
Wait, how did you get that?
Alright, so I accidentally wrote a negative 3x. I don't mind fixing it. So that becomes positive. That's positive. So then this is where it all kind of falls apart. Right? So we'll start from this spot. I just copied down a negative for some reason. So this gives me 4x equals 3x minus 1. I subtract 3x from both sides. And I get that x is equal to negative 1. Alright, sorry about that. So here we go. Let's use the same method. We're going to take the log of both sides. Alright, this is where we get down to the nitty-gritty, okay? I'm going to pull the x out. Okay. We cannot get a whole number value for 7 log 2, right? So we're going to have to now count on our calculator. Log base 10 of 10 is 1. So I get that x is equal to 7 log base 2. That's a good answer. Sorry, log base 10 of 2. That's a good answer, but I can get a decimal approximation as well. And how do I do that? I go to my handy-dandy calculator. And I type in 7 log 2. Guys, this button right here. That button, that log button is log base 10. So I hit 7 log 2. And it spits out 2.107 blah blah blah. We're going to round to the thousandths place. So we'll call it 2.107. Now when I put my answer here, I'm going to have to say that that's an approximation. So no longer using the equal sign, but saying approximately 2.107. Let's do the same thing then. Take the log of both sides. We're going to pull that exponent out to the front, just the same as we've been doing. Log base 10 of 10 is 1. So all I have left on my left side is x plus x squared plus 1. I've got to subtract 1 from both sides. I can't subtract it from that, so I'm just going to leave it as a minus 1 here. So I have x squared equals log base 10 of 15 minus 1. And now, I don't want to know what x squared is, I want to know what x is. So how do I get that square to go away? I take the square root of both sides. Square root of x squared is x. And remember, when you take the square root of both sides, remember, you have to consider both positive and negative values. So this becomes the square root of log base 10 of 15 minus 1. That's your final answer, right? You could write it as the positive and the negative. And then we can go into our handy-dandy calculator and get an approximation for that, which we will do right now. 15. And I'll show you how to enter, what keystrokes to enter in for that. So you're going to hit the square root of log 15. Make sure to close your parentheses so that 1's not in there, or you will get the wrong answer. You hit enter, and that's going to be approximately, if we're rounding to the thousandths place, it's going to be approximately 0.42. So, 0.42. Right. Let's go ahead and apply that same deal to this one, to C. So I'm going to take the log of both sides again. Same thing we're going to do with these exponential equations. If we're going to solve them using logarithms, we're always going to take the log of both sides first. The second step, we'll always pull out our exponents. Now, what the heck? I want x by itself, right? How am I going to get it by itself? Yeah, I can divide, right? If this says x times log of 4, right? So if I want log of 4 to go away, I can just divide both sides by log of 4. So that's 1 there, right? And that becomes, so x then, the exact answer is 3 log base 10 of 5 over log of 4. And we can put that in our handy-dandy calculator. Did I not put in the right numbers? Yes, 3 log 5. Did I write that? Oh, thank you. I got the 5 and the 4 wrong. So that's a 5. And here is 4. And we get approximately 3.483. Okay? Approximately 3.483. Oops, that is statistics. Oops. So we get x is approximately 3.483, and that is all. You have finally finished this lesson. Your homework, I'll post it on the website. I think I might have already done it. But it is 1A through 1G, 3A, 3C, 4A, 4C, 5A, 5C, and 10A through 10C.
Scrum, that's a lot of work.
I could just give you 1, 3, 4, 5, 10.
I'm not saying that. All right.